Okay, so we're gonna talk about encryption today. We're gonna do unit 10. If we can download your assignment and your notes. And then we'll talk a little bit about the practice test. I think I have a solution for it. I was just thinking about that now. Okay, so in this week, we're gonna touch on hash cryptography, a little bit of how the keys work, with also talking about PKI. So let me remove some of these extra bars here. So when we're using encryption, basically we're converting plain text into something that's not readable. Ultimately, every encryption has its own algorithm, or you can think of it like a way to calculate the or convert plain text into something that's not readable. So a lot of the encryption uses certain type of equation or procedures in making something that's readable into something that's not readable. So we would see this as referring to something like scramble. The easiest encryption that you would see that we normally teach students when we introduce them to encryption is Caesar cipher. And Caesar cipher was created by Caesar himself, right? He would use the alphabet letters and do the shift. It's also known as shift ciphering. So every character would be shift down a certain value, like let's say I put shift 7, so you just count down to the 7th character from the actual letter, and then that will be the replacement value. So Caesar used this to display or to transfer the message from one area to another, and he would tattoo that to the scalp of a slave and then send the slave to a location where his general would be able to interpret that message, right? And that's how he was able to tackle a lot of the attacks. So back then, there were a lot of different techniques on how we would change something that is normally read or understood by the human to something that is more difficult and needs to be converted or decrypted, right? So encryption is a way that we can let the system modify your plain text into something that's not readable. In encryption, we would achieve CI, confidentiality and integrity. So ultimately, the integrity part is going to be based on the hash value. So for example, if we are looking at an encrypted file, right, the original file would have a certain hash value. And when we apply the algorithm, it would use the hash value for the key to be able to generate that particular encryption. So the hash is just a number that is calculated for the data, and it's normally displayed in hexadecimal value or a certain numerical value that represent the hash. It will be a long string. Confidentiality is because we are going to use a key to lock it, maybe the same key to open or a different keys to open. So when you're using symmetric key, just like how you lock and unlock your house, that same key is used to lock the door, and that same exact key is used to unlock the door. Now, the challenge with symmetric key is how you exchange your key is very important. So if I need you to enter my house, I have to find a way to pass that key to you, so that way you can unlock the door and enter the house, correct? So when we decrypt, it's the same thing. If you're using symmetric key, the exchange process is very important because the key can get intercepted or duplicated and be able to unlock. So symmetric means that it's identical. So you're using the same key. Asymmetric encryption is a way that you can use two different keys. Just think out of your door lock. Let's say that I have key 1 to lock the door, but key 2 to unlock the door, right? So asymmetric key does that. You would use a public key to encrypt your message and a private key to decrypt your message. Well, we can also reverse that process. We can use a private key to encrypt the message then the public key to decrypt. But normally the private key is needed to decrypt, but the public is encrypt. So that way you don't need to have a share of the same key. But with this, you have to generate what's known as a certificate. So I want to use this opportunity to show you what a certificate looks like in Windows environment. You're going to see that in Windows 10 today. But we would have a certificate authority, a CA, which is a server role that we can give out certificate. And whenever that you would use HTTPS to log into your online account securely, right? The website requires a certificate, and that is already authorized by a CA through their web server system and also their authentication system. Okay, so let's talk about question 1. It asks you to describe how hash can be used for data integrity. And in the past, we learned a little bit about hash. So hash simply is an algorithm that has a fixed string of bits or hexadecimal character. Hexadecimal have 16 digits, right? 0 through 9 and 8 through 11. Often used for addresses or a certain type of value that's represented in the system, like hash. And in hash algorithm, ideally, it cannot be reversed or recreated for the original data. That's the whole point, right? So that way, somebody cannot generate that same or a different value to represent that file. So it is a unique value that's assigned to that particular object in the system. So whenever that you modify your file, your hash is changed. So the way that we know that the file is intact is when we look at the hash value and it stays the same, right? We compare the hash before and after. It is useful in verifying integrity for the data that is in motion, being exchanged or sent. And we would do this when the data crossed into something that's not secure, right? So it's a good way for us to make sure that the data is intact. So when you receive the data, you can find the hash value of that file or that data and compare it to the original data that was sent. So if I created file 1 and I'm sending that to you, right? So my file 1, when I save it, it would have a hash value. And that hash is then compared to when you receive the file 1, you will check for the hash value. If it's exactly matching, if it's exactly the same, then it has integrity. It hasn't been changed, right? So we can use that to determine if the data is altered. So in encryption, we learned that the reason why we use encryption is we want to make sure that our files stay intact, our data has integrity. That's the whole point, to protect the data. So it provides assurances that the data has not been modified. And hashing ensures that the data retains integrity. So whenever that you use encryption, you often see that hashing is also incorporated for encryption. And confidentiality to ensure that the data is only being viewed or accessed by that particular user or those users, right? The authorized user, the one that's intended for the data. So encryption really protects the confidentiality of data. In the case that it falls into the wrong hand, they will not be able to read the data or see the data because it is encrypted. It's not intended for unauthorized users, so those unauthorized users would not be able to see the data because they don't have the key to decrypt, right? The reason why we lock the house is to prevent people from entering, people that we don't know from entering our house. And that's the same point, is when we encrypt data, we want to make sure that we protect our data from users that are not supposed to access the data. And for those who are supposed to access the data, they would have the key to unlock the data, right? Just like how your family members would have the key to your house to have access to your home. So decryption is the process of converting encrypted data into plain text, so that way it can be seen or readable again. And we've talked about using either symmetric key or asymmetric key. So when you're using things that require PKI, public key infrastructure, it would use two keys, asymmetric keys. One to encrypt and one to decrypt, such as RSA, right? Whenever that we're trying to use secure shell to connect to maybe a switch or a router, and SSH required that we use PKI, public key infrastructure. So when you hear that, you would know that it uses two different keys, one to lock and one to unlock. Now, in some encryption, and you often see this with streaming web encryption, it would use symmetric key, right? One to lock and one to unlock, same key to unlock. Any question? So make sure we know what encryption is, make sure we know symmetric and asymmetric key for final exam. So when you hear the term streaming cipher, that means that it's gonna stream one bit at a time. So it's gonna take one bit, encrypt it, and send it, right? And this is what you see with web, because that way it can be constant and it can be fast. And then you would hear block cipher. Most of you are familiar with cryptocurrency, right? You hear that all the time, blockchain encryption. But block cipher simply is chunking it into groups, right? Let's say that I would chunk 16-bit and it's gonna lock each time, it's gonna be chunking it to 16-bit before it sends. So if my data is 32 megabytes, you're gonna have many blocks of 16-bit each time. Now, our block size could be larger or smaller. It really depends on the algorithm of encryption. The more modern day encryption algorithm would chunk it into a larger block, right? And blockchain simply is to chain it with an operation, so that way when it decrypts, it has to decrypt in chain, right? So just think of it like, if I have many rooms in my house, in order to open room number 10, I have to open room number 1, then 2, then 3, then 4, and it is in a chain process, right? That is just a slow down process for security instead of being able to open all the room at once, right? So when we block it, we would chunk it into a group of bits, into blocks, and then be able to encrypt. And then steganography, this is very common in cybersecurity as well. You see this with malware. You see this with also a way for us to protect our files, to hide our files within the data. So when you see things that are embedded, that's hidden inside. So for example, I might have a PDF and I can embed code into the PDF. So when people download it, it's going to activate that code, right? There are many type of file that can be malicious, and you can construct a file to incorporate, you know, whatever that you need to do. So coming from an attacker standpoint or a malicious user standpoint, there are tools that you can do this, right? To be able to build out some file that looks benign, but it would contain additional information. But from an administration standpoint,
you can use steganography to be able to hide your files that is not visible to many of the users, right? And it's intended for to evade a lot of like the attacker, the unauthorized users are looking for sensitive data. And you can use it both ways. Okay. So we already talked about encryption and confidentiality and integrity for question 2. In question 3, it says, how is a hash different than a checksum? So a hash, we already talked about a hash is a value that's given to an object once it's created, and we can use that to check to see if its integrity. A hash has longer numbers, and it's used for strong cryptographic implementation. So hash is often used for encryption. So when you create a password, where your password is stored, there's a hash, right? A value for that password, because that password is then being encrypted for protection. Checksum is just a small piece of data, 1 or 2 bits that's used to verify the data integrity. It can look at the entire data, whether it is all there, right? Or if something is missing. Checksum can be used in many different ways. So if you're looking at RAM when it's doing checksum, it's just simply doing odd and even. I don't know if your instructor talked about this, but it's looking at the data that's written into RAM based on odd or even value, based on the addition of binary. If it's intended, so let's say that my data is supposed to have an odd output, right? And it, for some reason, when we run the checksum and it comes up even, there's a mismatch, that means I have missing data. So checksum is to look at the entirety of the data, whether all the pieces are there or if something is missing, right? And in the case where if we're looking at integrity, we can see that. If my data has been corrupted, then I might have something that represents this. So it really depends on the context that we're using checksum for. Now, for hash, we learned that there are many different hash algorithms, including NV5, Message Digest 5, version 5, right? This has been compromised, but it's still being used for a lot of things. Whenever that you go and download the software, you often see that they provide the hash value in NV5 or SHA, SHA-256, right? Or in variation of the more common hash algorithm. It is very common to use MD5 for email, for files, like I download a text file or even an executable file to install my Wireshark or whatever, right? That value can, on the website, should match the value once I download and install, right? Because that way I would know that there's not malware impacted type of file that is being distributed from the website. We can also use it for storage purposes, for downloads, for executable files. And we know that the vulnerabilities exist in MD5, so it shouldn't be used often because it creates security risk. So something has been already compromised, we would try to use it less or even none. Because if that hash algorithm has already been jeopardized, likely that if you have it on your network or your systems, right, someone can break that hash algorithm. And NSA came up with a couple versions of SHA. SHA-1 or SHA-2. And sometimes you would also see hash algorithm such as SHA-1 or SHA-2 being used, right? MD5 is very common. SHA-256 is very common, right? But you also see, so NSA is responsible for creating those versions. Any question? Okay. So I want to clarify the difference between digital signature and also encryption, because I think a lot of people tend to mix it up. We already know authentication means that it validates your identity, right? Like when you type in username and your password, that's an authentication process. Because you issuing the password, it validates who you are as a user identity, okay? Digital signature, it is a way that we would tell the system or others that you are authentic, that the document is authentic, okay? So that means that you have to have authentication, either a passphrase or have some kind of access capability. Hello. And non-repudiation and integrity. So when we say non-repudiation, it's going to rely on timestamp. So that way I cannot repudiate, I cannot argue that it didn't happen because the system tracked that. It accounted for that occurrence. So when I digitally sign, just like how you sign a piece of legal document, you put down the date and the time. So when you initiate that digital signature for that document, it creates a timestamp and it's authentic to that system at that moment in time, right? So we cannot argue that it didn't happen. Now the attacker, they can go in and, with the proper tool, sometimes they would be able to modify information logs that we would see. But the whole point in having a digital signature is really to say that that piece of document, that file is authentic because it was validated through that signature. Okay. Okay, so we talked about checksum and hash, how they're different. MD5 hash, these are the SHA. Remember, the 0 is not used, 1 and 2, and then version 3 is not made by NSA, right? It is similar to SHA-2, but it's made by a different organization. And same thing with all the other hash algorithm, we want to compare for good hash, okay? You can use things like hash ID. I think we've seen that before. And then we can also use HMAC, which is hash-based message authentication code. This is just a string that's similar to hash MD5 or SHA-1. It uses secret key to generate. So it uses a key to be able to generate this. And you do see some of this implementation in web authentication or remote access. Okay. So the process is described here. Once the sender generate that hash, right? If being attacked, the attacker would try to insert the hash in the modified message. And then when it gets to the recipient computer, the hash modified message is then compared to see if it's the same. If we use HMAC, because it's using the same secret key, only the sender and the receiver would have those keys. That elevates the security a little bit. So when it calculates the hash, it's going to look for that key. So that's an element, that's an extra element that we have outside of just hash comparison for integrity in the message exchange, right? Because if they captured your hash, of course it's gonna check out because it's exactly the same. But if you need to have a key to be used with that hash, that's an additional security level, because now, even if they captured your hash and they don't have your key, then it doesn't work, right? So that elevates the security level a little bit. So you can see the process and the information there. Now, RIPE-MD or RIPE-MD, this is Race Integrity Primitives Evaluation Message Digest. We need to know these things for certifications, okay? This is a hash function similar to all the other hashes to compare for integrity. But it is longer in length to some of the basic hash algorithm, 160-bit. It uses fixed size hashes, so that's gonna be just the exact size. But you can also have other versions, at least 128, 256, and 320. Now, in order to generate hash, even with the hash algorithm, the software has to enumerate through the characters, right? So the longer your bit size, the slower that will be for the attacker to rebuild that hash value. So if they can't capture the hash, they're gonna try to enumerate through the hash. So a lot of the times we want to go with a decent bit size, just like how your password, right? When they crack your password, the longer the length, the longer the time that it's gonna take them to find that password or to enumerate through the characters to match the password. So if we want to have hash values because it uses hexadecimal or a different number system, we want to have longer combinations or more time to match that hash value. So bit size is important. And for hashing the files, it's just a one-way function. So we would use that for every single thing that we save. So your system keep track of that. So if the attacker wants to do a hash collision, simply it is using the same hash value for different things. So if I have file 1 and file 2, a hash collision occurs when they both have the same hash value. It's not supposed to be that way, right? It can be forced to be that way, but every object needs to have a unique value. Otherwise, you have a hash collision, right? So when they perform a hash collision attack, often it is in MD5 because it is reversible. It's been compromised. So you would see that they would use the same hash value for other files or other inputs, okay? All right, so let's go and answer some of the additional questions. So on this one, it's really easy. You can open up your command prompt for number 6. If you haven't done that, I'll do that on my laptop. So it's slightly different than yours, but you can just search for CMD, follow the steps for number 6. And you don't have to be a sysadmin for this. You can do this as a user. I tested it, right? Open up your command prompt. Then I want to move into my desktop because that's where I'm going to save the file. So CD desktop. And if you wanted to do it on your virtual machine, you can. You can do it on your regular desktop. So once I'm on my desktop, and you can see that with that's important, right? We want to check to see our path right here. It should say desktop before we start the next command, which is C. So when you're doing an echo, right, it's going to append all the text in the string right here in the quotation mark to a file destination. So we're going to do echo. Let me pull this down. So we're going to do an echo command. So it's going to append to a file, right? And we're going to use the quotation mark to represent the string. This is a secret file. Close the quotation mark, and you're going to need the arrow because you have to put it into the destination file. So we're going to say secret.txt. So once you append it to the secret file, you are going to use a tool in Windows called cert utility. So that's going to generate the hash file for your secret.txt, but for MD5, right? So cert util is simply a command to activate because the hash file, but these two with the option here, it knows that you are going to create a hash file, but you have to use cert util in order to do that for Windows system. So we're going to do a cert util space hyphen hash file. And we're going to tell which file we're going to create the hash file for. And the algorithm for the hash, MD5. So on yours, it's going to be different than mine, right? It tells you that this is an MD5 hash for your file. And this is the hash value. And it's completed successfully. So now, after this step, you know how to create a hash file for your files, right?
Stacy, on number 6, number E, does that have to be entered in the computer also?
Yes, you need to take this information and put that as an answer here. Okay, are we good? So if the Windows 10 or 11 supports different hash algorithm, right, you can specify, and you can also look at Microsoft documentation on cert util with the option hash file. So that way you'll be able to see, oh, can I do this for SHA-1, SHA-1, or SHA version 2, 256? And every operating system would support a group of different hash algorithms, right? So earlier we talked a little bit about HMAC for HMAC. The protocols that would be used with this is going to be IP security that's used for remote access. For your remote access server, your RRAS. And then TLS, you often see TLS with HTTPS, secure website that you log into. So for authentication for web application, you often see that we can implement HMAC.
Doesn't,
So you need to cert util. Hash file is one word. Has to be identical to the instruction. And we talked about hash collision where two inputs have the same hash value. It's not supposed to be, right? Every object or every input needs to have different value. So hash algorithm creates the same hash from different input, and MD5 is susceptible to hash collision. Any questions? Did it work?
well, now it says it failed.
CD desktop. But you have to make a file first. So did this work? This is a secret file, so that worked. So cert util.
Do this again.
Yeah, you have to type it, but file on desktop?
Yes.
Is this, oh, so utility thing. You logged in as yourself, you're not using guest room. You can skip this for now. I have to help you later on, so. Come back to it later. Just do the next few. Okay. So I harp about this in all my other classes because we touch on like how we would do password attack. And you have seen we've done offline attack in one of our lab a couple weeks ago, right? When we did brute force. So when you see offline attack, usually if your password is more than 5 characters, it's gonna take a long time. Depending on your system that you're using for attack. So brute force is usually taking a long time through enumeration, processing power, RAM, connection, all of that's important. Pass the hash is a very common technique where instead of cracking the password, they can just capture the hash that you use to store the encrypted password, right? Cain Enable is really great for doing this along with other password cracking tool. It uses, for Microsoft system, it uses the LM and TLM technology, which is older, but Microsoft Windows 10 and 11 still have this in the back for compatibility upgrading from the other version of Windows, right? Anything from Windows NT going forward. So what you see is this is a way that they can capture your hash for the generated password that you created, even though your password is encrypted. And if they have higher privilege, like the admin privilege, they can use SAM, which is a database that is used to track your security token. Whenever that you log into RCCD network, a token is given to you from SAM, right? If you are only on the local system, it uses the sub authority. So it is simply a way to check to see what kind of access you have based on your token. So in a network access level, they would use this area to do the hash attack from pass the hash, right? We often call it PTS attack. Now on the birthday attack, this is to use a mathematical theorem. This is a pigeonhole equation based type of attack, because there are only so many ways that we would look at numerical values. So for example, right, there are only 12 months in a year. And I can securely say, right, I can strongly say that everybody in here would be born, at least one person in here is going to be born in January, right? Because there are more than 12 people in the room. There's at least one person going to be born in February or November or December, because it's looking at how many people is going to encompass 100% for the 12 months. So if we have more than 12 people in the room, we can confidently say that at least one person is going to be that. So in the birthday attack, it simply is a way that they would create a password that have the same hash, which is hash collision, to the user password. And they would implement the birthday paradox where it would be randomly generated. If we're looking at random group of people, at least 50% of the people would have the same day of birth, not the year. Why is that? Because if you're looking at the 12 months, right, 23 people, that's almost double the amount of the 12 months. And then if you have more people, let's say 50 people, we can safely say that at least one person or at least two would have the same day in the month. Like let's say the 2nd, doesn't matter April or May, right? But on the 2nd of the month. So the birthday attack is simply looking at random generation of the probability in based on the guesses that you would get in the hash collision. Okay. So, and this plays into combinatorics. If you've taken discrete math, right? We talked a little bit about how this can be implemented. It's heavily used in computer science for pigeonhole equation and so on. So for MD5, because it's using 128 bits, it is susceptible to the collision because there is at least 50% chance that there is a match in the same hash. So in that case, if you're using something that has higher bit size and more of a difficult algorithm, it is less susceptible to birthday attack. It doesn't mean that it won't happen, it just takes longer, right? We know that for sure. So for question 9, it says, how can an organization reduce the risk of the birthday attack? Just to use a higher bit size hash algorithm. And we mentioned that at least anything above 128 bit, such as 512 or higher. This will decrease the probability of hash collision. So the higher the bit size, the more combinations that they have to generate based on that bit size, right? And that means that the system needs to compute that long string to represent that 512 bits. So that would take longer for the attacker to find a match in the hash for hash collision. It would then use random generator to enumerate, right? So in hash attack, a lot of the time they would use a known based hash guess type of program to generate matching hashes. So the longer the bit size, just the longer the time that you have. So it decreases the probability of the hash collision. That's all. And when we salt, in just very similar to salting password, right? When we salt in a password, we're simply adding some bits into the password length, right? Making it confusing for someone to crack the password. Similar to that, we would salt the hash by adding random data. Think of it like stuffing it in various part of the hash key. So it would generate a different type of output compared to the original hash. So you're really technically doing this to fool the cracker, the person who's trying to crack the hash. And even when the input is the same, because it's implementing certain area or various area that's gonna stuff. So when you take away the salt, it's still the same, right? So with or without the salt, it should still represent that same object. But salting is just simply stuffing it so that way it looks different to someone who doesn't have access to that. So the unique hash produced by adding salt that can protect against different attack vectors, such as rainbow table attack. So in a rainbow table attack, what do? They obtain what kind of table? So they would be able to utilize many different type of password table and correlate that across, right? Across the spectrum of the rainbow, right? To be able to quickly find the password. So that's a rainbow attack. And it also, rainbow attack table can also contain hashes of the password, right? So, and these tables are shared across many different channel online. And then the dictionary attack is just how good is their list of dictionary. So dictionary simply, the list would contain common words, could be names, right? And you name it. So the longer their list, the more likely chance that they would get a hit on the password if the user have a common word implemented in their password. Right, such as God or sex, right? That will probably pull up first on the list in the dictionary. And then brute force attack is simply enumerating through numbers and characters or letters until it finds a match. So salting it simply randomly place additional things to it, like stuffing it, making it look like it's different, but it is not, right? And same thing with the concept for salting password. Salt is random data that is used for additional input to a one-way function of hash data. And that, so you simply, when you salt the password, you simply salt the hash of the password, get it? Because the hash is a way to access the real password in plain text. Hash is used for password encryption. And when you salt your password, it's just a way to safeguard your how you store your password. Because in all OS's password is encrypted, right? And in order to encrypt it, once you create that password, right, it's stored, so it creates a hash. So when we salt the hash of that password, simply is salting the password. So just simply adding values or random values to it. Any questions? Okay. So I know a lot of the textbook, they don't. So here, right, it talks about that. They don't go into some of the more specific example. We'll touch on that in a little bit. But here it talks about password-based key derivation function 2. This one uses at least 54 bits for salt, and it does pseudo-random, right? If you took my programming class, you have gone through, all programming classes should learn about random generator. And when we see pseudo-random is something that looks like random, but is not truly random. The only time that we can have a true random of something is when we implement a system time. So for example, I say something right now, a second later, it will be something different if I say random things, right? Because a second later is a different time in your system. So a true random generator would implement a system time, right? So a lot of the random generator that you see out there is called pseudo-random. It seeds at a spot, a value. Let's say that my generator starts at 1, right? And I would say that, yes, it's gonna, the way that the program is written, it's maybe multiplied by 8 divided by whatever. It looks random, right? But when you run it, because it seats at the same position, it always gonna give you same value, okay? So when we see pseudo-random, there's a way that you can reverse engineer this if you know where the seed is, right? Mathematically, we can look back and recalculate it. Bcrypt is known as blowfish block cipher. This was used for Linux system. This is what Linux system used for shadow password storage. It uses bcrypt. Okay. We already talked a little bit about this, so I give you a comparison table again for these, even though it was listed above. So when you encrypted data, when we implement encryption, we need to focus on these. Data at rest, that data that's archived and stored, right? Not touched. So let's say that you have backup, you might have data that's archived for older system from 1970s, and they might not touch it for a long time. And then you have data in motion or data in transit. Those are data that's being sent via email, messages, right? Access, downloads. And then data in use. People are modifying this data through applications. For example, finance department might modify some kind of document. That's data in use. So two things that you need to focus on when you select your encryption. Encryption sounds really easy, but you're going to see tons and tons of things out there. How good is the algorithm, right? It is simply a mathematical calculation of the data. Some are unbreakable, most of them are, right? But ultimately it is a mathematical equation. With time and processing power, it can produce. So a lot of the encryption plays on prime numbers, right? Do you guys know why they use prime numbers? You guys know what prime numbers are? 1, 3, right? Yes, I'm familiar with Amazon Prime Day, I'm sure, right? So to calculate out, right, prime number, that can take years and years, right? So can you find a solution to a very large prime number? Sure. Just like how people can say, how close can you get with pi, the value 3.147, etc., right? NASA claimed that they have like the closest to the municipal, however many thousand, hundred millionth of a digit, right? So prime number is similarly in the concept in that you need computation power to generate a very large prime value, and that can take many, many, many years, right? If you manually do it, that could take centuries, right? So we use computer to calculate because ultimately it's a calculator. So a lot of the algorithm that you see out in the market plays on prime numbers. And you know that with prime numbers, can someone predict the value? Sure, if they have processing power and time, right? So when you purchase encryption, always think about the algorithm and your key length, okay? It will tell you 256-bit, 512-bit, 1024-bit. The bit size, right, is important because key can also be cracked. Just like how your wireless key can be cracked, right? How it is random or pseudo-random. True random is always the best. And this is for the ethical hacking students, or if you are pursuing pen testing and that. Initiation vector, this is a value that's often get overlooked. And it's really important when you use this. A lot of the time we see this when we run Wireshark and things like that. Initiation vector is a starting value for cryptographic algorithm. And this is when they scan your packet. If they see this leads them to decryption for your data, especially web data, okay? So all of the things that I put down here are important things that you need to focus on when you're looking at encryption solutions, okay? There's nothing that's unbreakable. People claim that, they're lying to you, right? Give them time, years, and processing power. That's all it takes. But, you know, and then creativity too. If they can't go this way, they will go an alternate way. There are ways to, instead of calculate out the value, there's a way to break the value, right? So it's really depending on the attacker. So nothing is impossible, right? So it's important that we know that, because a lot of time people sell security solutions with a lot of promises. Okay. So how can you determine the integrity of the message if it is jeopardized? Easy. Hash comparison. If the message, if the hashes are different, lost integrity. And then 14, we talked about encryption on how we can protect data that's stored, data that's being sent, data that's being used. So for data at rest, those are stored data. We would encrypt the container or the storage, like the drive, right? It always is important that you make a decision to encrypt things that are, when you have objects, the container protection is important. Permission assignment to the container is important. Because management and administration capability is gonna be a lot more reduced compared to if you're trying to protect 1 million objects instead of 1,000 containers. Okay, so put them into a location where you can assign permission, where you can encrypt, right? We would protect the storage that contains those objects, the folders, the subfolders, the files. And then data in transit, those are the data that's being in and out of your network. If you're using web-based, use TLS. And then we would salt the hashes for the encryption and also use email encryption. Personal use, there are many different type of email based encryption that are free. It's just gonna be responding a little slower, right? But you are more protected in how you're exchanging data. So if your data is very sensitive, encrypt your email. Encrypt the data that goes into your email. And then how you share your keys for that's gonna be important. A lot of people use passphrase based type of email encryption. So for example, right, like I want to send you a very important document about your health information, and I want to encrypt that data and put it in email, right? And with that, I usually would create a passphrase or a password. Most of them are password oriented. And then I just tell you what that is so that way you can open it. But how I communicate that password with you is important, right? So if I put it in plain text in another email and that email is intercepted, well, there goes the encryption. No point, right? And then for data in use, that's on the computer, not encrypted while it's used. Applications can be used to encrypt, to store and decrypt the data in use. So you have to encrypt it when it's not in use, when it's stored. So for example, I create file 1, I encrypt it, and then my team members would then need to decrypt it to modify my file 1, right? So, and that would require processing and access, authentication, and all of these other things, right? So it's gonna be application oriented. So the difference between block and stream cipher, you just need to know that block encrypts data in chunks or block size. Sometimes 64-bit, sometimes 128 or larger. So for large files, block cipher is ideal because it's able to chunk that file into messages. We know that data don't come in one set of order, right? 1 through 10. It doesn't do it that way. When we send things over the network, the 8th packet might arrive sooner, and that piece of data is not. It's all out of order until it gets represented through the application in order, right? So chunking up the data, it's ideal when you're dealing with large file. And you would encrypt the blocks separately. Okay. So we would normally see this in database fields because so when we say fields, those are columns in the database table, right? It is effective for files or database fields. So for example, password columns, bank account columns, And then we can stream. And this is often used for web communication or web traffic. It is efficient because it's 1 bit at a time. And when you don't have a known size of data, it could be large, it could be small, it's varying. So when we don't know the actual data size, if it's large, we can go with the block, right? It might be tiny. So we would then use stream. And it would send continuously over the network. But we should never, ever reuse the key. Because when you recycle the key can be captured and it will be decrypting. And this is how a lot of the time they break web. Any question? So security plus, they expect you to know these things, right? And encryption is not something that's easy to digest. A lot of the times you have to kind of learn the terminology and then understand the technology behind it. So you can use, so before we answer 16, let's go over some of the options. Okay, sorry if you're typing, I'm going to switch real quick. So here are the cipher modes, right? You got electronic code book, your ECB. This is the simplest. Takes the plain text, put it into blocks, encrypt each block, use the same key. It's like, think of a train, right? Like I have all these cars on the train and I'm using the same key to lock each of those cars. That's your ECB. Your cipher block chaining, this is good to know. Your CBC, this is currently a lot of the cryptocurrency technology, right? This has been around for many, many years. It's just crypto after Bitcoin, right, blew up and then everybody implements it. It uses symmetric block cipher. It uses IV for randomization and encryption of the first block. It combines the subsequent block with the previous block using exclusive OR operations. It is just operators that's implemented for the code for the blocks. Each block encryption would be dependent on the previous block. My analogy for it is like having 10 rooms, right? In order to enter the room number 10, you have to first enter room 1, then open room 2, and so on, right? And that's how it encrypts and decrypts. So it's dependent on the previous block. I cannot open 3 without 2. I cannot open 2 without 1, right? I cannot jump in the middle and open 5 without the opening the 4, which is previously dependent on 3 and 2 and 1. That's why it's called chaining. It is a huge delay because there's a pipeline delay, and most of the time they use independent servers to be able to supplement for the chaining process with this for this particular mode. Your counter, it converts your block into a stream. It combines your IV and it uses the result to encrypt plain text block. It's using the same IV combination with the counter value. But it's using different encryption key for each block. This requires more system power, but it is more effective than the other two. And then you got your GCN. This is used for many block ciphers. It combines CTN with the counter mode for GCN for authentication. It does not authenticate the users or the system, but it gives you integrity and confidentiality using hash-based technique. Okay, so my selection was the counter. You can choose any of these of your choice, right? But in general, these are the common mode that you would see for encryption. So encryption uses a certain mode, right? Think of it like methods. So I chose counter. I felt counter could be effectively used because number one, it converts block cipher to stream, so it's efficient. Number two, it does a combination of IV. IV can be guessed, but with the counter, so that way each of the block can be encrypted, but using the same IV in combination. That's probably the downfall of the counter mode. But you're welcome to use GCM or the other ones, right? And I'm sure if you're into cryptocurrency, you probably watch a lot of tutorial videos on blockchaining and how these servers are providing transaction lists to the other servers and so on. But it's been breached, so any question? Okay, I'm gonna move these two down. I'm sorry. To the next page. Check the space. It's easy to see. Okay, so you can select any of the type of the encryption that you want, and then you can provide some reasons why you select it. So before we answer 17, right, we should look at the notes and look at the different type of encryption and what kind of technology is being implemented for each of the encryption type. Okay, sorry. Let's go through here. So I broke this down into two categories. One is symmetric, the other one is asymmetric. And we already learned that symmetric uses the same key, right? The same key to the house to open and close. So it uses a secret encryption key or the session encryption key. And the key-based ciphering is substitution. So usually, it would substitute with different letters. This is the common one that you see. This is what your smartphone technology use and also your wireless technology use at home. AES, this is the preferred choice. Knock on wood, right? It hasn't been reached yet, so compromise. So advanced encryption standard. It uses 128-bit block. NIST adapted this as part of Ringdell encryption algorithm. Remains within the top 15 for many years. The key length is between 128 to 256, so the decent key. The reason why I selected this one is I really like that it is fast. And this is why it's used for wireless. So Apple technology has implemented AES long ago after, I think, BlackBerry kind of died down. They were the first one to really use encryption in smart devices because they were the first in the market for that area with the PDAs. And then Apple came into play, right, with the iOS, and then starting with the iPhone 2, they implemented encryption for their data because there was mobile security issues. So you would see that the technology had gradually evolved into what we use today. And then another one that you often hear about that is symmetric and it is block-based is DES. And this uses 60-bit block, a little bit different in size compared to advanced encryption standard. The key length is smaller though, so key can be cracked with brute force because it is 60 bits. Triple DES is the later, more advanced version. It also uses block size. It requires 3 passes using multiple keys. So think of it like box within a box within a box, right? In order to open what's inside the inside box, you have to open the outside box with 1 key, then the next box with another key, and the third round with the third key. So you need 3 passes with 3 different keys. That just slows down everything because DES been jeopardized. It's not recommended for today's use, like I put, right? So triple DES is just that version, but locked with multiple keys. So it is more secure as it buys more time. And it is not as used often compared to AES, but is good for alternative. So you can see that we would start with the key length from 56 and it goes to 168 bit. RC4, Ron Rivas, right? He still shows up at various conventions and security. So if you ever get a chance to meet him, it'll be a good thing for you because he's very famous for creating cipher. So he speaks at various events. So RC stands for Ron's code. And in the prior versions been compromised. This is a stream-based cipher, but it is symmetric. It uses the same key. But the length can go from 40 to 2 gigs, right? Which is pretty decent. It's often used for web communication. NSA announced that they tested and they breached wrong codes version 4, and they recommended using AES. Earlier you learned about bcrypt is based on blowfish and twofish. This is symmetric block cipher. 64-bit blocks support key length between 32 and 448. Your book doesn't contain this, the recommended book, right? Bruce Schneier designed blowfish and replaced it with DES and later on triple DES. It is faster than AES 256. There are many algorithms that's faster, that's government use as well. It encrypts data at 64-bit block, whereas AES encrypts at 128 or 256-bit block. Twofish uses 128-bit, right? Similar key length. It remains within the top 15. So if you want things that are fast, this is why Linux system uses blowfish-based technology, because it's lightweight and it's fast. Okay. Then you got asymmetric. We talked about using 2 different keys. But before we go into that, let's take a look at these questions. So you can go down the list and select the ones that you want. AES is going to come up within the top, right? If you talk to any people in security, they often go to that because that's one of the common ones. But you're welcome to choose the other. I chose AES, which is Advanced Encryption Standard. The reason why I chose it is because it's in everything that we use today. And we need to know about it. So your data encrypts in 128-bit blocks, but it can also use 256-bit block. It is one of the top 15 algorithm. Your key length is 128, 192, and 256-bit. So decent key length. So if I select this, I would use the longer bit size key length, right? It is fast. It only requires 1 pass to encrypt and decrypt. Where triple DES require 3 passes, right? It is efficient. And it's good for small devices like your IoT, your smart devices, and wireless. It provides confidentiality because it is strong, and integrity. But if you pick the other ones, you would see the description below that, right? And you can provide that support. Well, sometimes you can research it. Any question? So we learned from earlier section the difference between symmetric and asymmetric encryption. It's how the keys are used, right? So symmetric use the same key to encrypt and decrypt. Asymmetric, so when you say something that's asymmetric, right, or there's asymmetry, that means that they are not identical. They're not exactly the same. They are different, right? So asymmetric encryption uses two keys, one to encrypt and the other to decrypt. So I can use my public key to encrypt the information only if the matching private key can decrypt. So when you use this encryption like RSA, Rivers-Sindel, right, you would generate two keys. One key the system is going to use to encrypt, and the other key you're going to use to decrypt. And the private key is always going to stay with that system, right? So I put down the information below. The public key encrypts the information, only the matching private keys to decrypt. The private key decrypts, or if you use a private key to encrypt the information, then the only matching public key can decrypt. So you can do the reverse. It is very strong. And it's recommended that you would use another form of encryption to exchange your key, which we often use symmetric to transport the keys. So you have to get the key to get to the keys, to get to the encryption. Now, symmetric encryption, we know that it's using the same key. And so that means that the key needs to be shared. Often that you would see substitution, or what I said, Caesar cipher, right? We would substitute the letter with the shifted value. Substitution cipher would then be used for key exchange. Don't use the same key to continue to encrypt and decrypt, right? We would do a one pass. And then on the next round, we would use a separate key. And that's how you can maintain where you store your key, how you exchange your keys. Very, very important for encryption. Keys needs to be changed for multiple encryption. Okay? Don't recycle your keys. Don't be lazy and recycle your keys. It's an audit issue. So it's the takeaway from this, right? You don't have to remember all the specific algorithm, but just remember the categories. How each category is different. Symmetric compared to asymmetric. And then earlier we touched a little bit on digital signature, and the later section talks about that too, but 19 asks you to describe digital signature, how it's used to provide assurances for authenticity, integrity, and non-repudiation. Authenticity, when you sign that document, right, using digital signature, as a signer, the certificate authority gives you a digital certificate. This is a file, right, that contains the validity of who you are as a signer. So this is used to track right? How we can, so the certificate authority is just a system role, right? That gives out these certificates. And it could be to from a local system or from a server standpoint. So certificate can be expired. So when we're looking at websites, when you go to certain websites and it says you don't have permission to access this page because your certificate has been expired, right? So if it's not managing the certificate properly, if you are not issue another certificate, you cannot access the web page. But ultimately, that certificate, when you digitally sign, it really validates, right, who you are based on your authentication to that system as a signer. Just like how when you sign legal document, you show them your ID and you put down your signature, it really validates who you are. And it validates, you know, that document that you signed. Then the integrity part is that the content doesn't change, right? As you digitally sign, it validates that there's no tampering to that document. So when your document is accepted as a digitally signed document, it's just saying that it's staying intact and the signer is legitimate. Then for the non-repudiation, it just proves to everyone that whatever that sign, it is an original. And when we say non-repudiation, it's just referring to the act of the signer denying that it occurred. So once you sign, you cannot go back. You cannot argue that I did not sign that document at that time, right? Because the system is your witness. So when you do a digital signature, the system validates to the world that at that moment in time, you are validated as the signer. You cannot argue that you did not sign. Okay? Because the system is your witness. And we can do this, we see this with our email system, right? With Adobe through an application. California does have a wet signature requirement. So even if you digitally sign most of the document, a lot of our more legal document requires that you have, right, sign in person, and then you have someone who there to witness, right, that you signed that document. But in other states, they only require digital signature because now after COVID, we understand how to work remotely and how to submit things via the web more effectively. So you would see digital signature is not something that we would do away with. It's very common and it's gonna stay. Any question? Right, so that's different than encryption. Encryption is to make sure that it's not viewable to the people who are not intended for. Sorry, there's more. So let me move these two down. So as you know, that web servers is probably the heightened, more targeted system. A lot of the time, web servers provides us access to web application, which is normally linked to database and other things. So when you sign in to pay your bill, you're connected through the web server, but then it also connected to a database and its application, so that way it can authenticate you and give you your account information through the database. So someone can perform what's known as a downgrade attack against your web server that uses HTTPS or SSL and TLS protocols in the back for encrypting web data, like your bank account or your credit card information. So if the organization is using SSL secure socket layer, it has vulnerability, and the attacker would exploit SSL by configuring their system so that way they could not use TLS. When they communicate or connect it with the server then would downgrade the security because TLS is higher in security compared to SSL, and SSL requires certificate as well. So if they scan against the web server and they realize, oh, the server is using SSL, I would set my system to use SSL. So that way the server would adjust, lower its security to serve me what I need. This will allow the attacker to launch SSL attack, such as padding Oracle or Poodle attack, which is known as downgrade legacy encryption attack. And after the server downgrades the SSL, the attacker can initiate man-in-the-middle attack and other things. Cross-site scripting. Normally, you see web attacks entail multiple forms of attacks, right? But a downgrade attack is to downgrade the security and forcing the server to make its adjustment to serve you as a client who's connecting to it and playing on its vulnerability to perform the attack. So it's important when you're footprinting the server, right? You need to determine what approach that you're going to use, and that's going to tell you what tools you can potentially use. Any question regarding downgrade attack for web servers? So when we select encryption, right, as I mentioned some of this earlier, you need to look at limitations. It's restriction and constraints. I harp about this to all my programming students and my computer science students. Every software have a constraint. Every program has a constraint. Your product have to be documented with constraints because there's no perfect design software, right? Even with AI generated software. So your limitations, your resources and constraints. So make sure that when you shop for the encryption technology, look for that. Speed and time, very important, right? We learned that streaming encryption is different than block encryption. And the larger the block, the longer it would take, more performance requirement, the resource that it would take. So resources and versus constraints, speed and time. Size and computational overhead. Because it might not just be processing one time, it might be many times for many users. So the implementation of that, you got to make sure that that's adaptable or scalable for your infrastructure or your systems. Okay. Entropy, randomness of the how good is the random? Is it truly random? Is it pseudo-random? Will there be error or predictability? Right? Hash algorithm is the same thing. Okay. When you select the hash, look at these areas. Is it guessable? So a true random needs to have an environmental input, like time, system time, in its environment. Pseudo-random is deterministic because it starts at the same place. Okay, like the seed is the same. We already talked about the key strength and the key length. So weak keys are small or shorts. And you don't have to put all of these down. These are notes for you to understand what key strength means, right? So shorter keys, no good. Longevity entails doubling the key size. That's going to give you more probability in the key generation of the product. So if it says the minimum is 128-bit, you want, and all the way up to, let's say, 2048, well, maybe 512 is the midpoint because you're able to double the key length there. And we don't reuse. Especially, right, for symmetric encryption keys. Okay. So, let's take this down because some of you are still typing this down, and I'm sorry that the answers are kind of long, but that's typical of like encryption. So for centralized certificate trust model, it says, how does the devices or the users obtain a certificate, right? Like when you log on to the website or when your system is communicating with the network. There is a server role that's called certificate authority, and its subset is called child CA or child certificate authority. This can be initiated in the network environment to distribute certificate. And we can set up the certificate with configuration that would tell when it's expired, right? Or when you can revoke a certificate. That means that we can take that away from a certain system. So for example, if someone is not supposed to have that access anymore because they didn't pay their subscription, right, to my web services like cloud or, you know, video access or streaming for game like Twitch, example, right? I can set up a way to automate the certificate, check for the subscription. If they didn't pay the subscription, revoke the certificate at that moment in time. So when we revoke a certificate, we make that certificate unavailable for that user or that system, right? And it needs to come from a root certificate authority. So in a network, when you first install the certificate authority, you can make it a root. It is usually a root. And then we can escalate that out to a subset because even when it's centralized, you don't want it to be dependent on one entity or one system. Because if that system goes down, there goes your distribution of certificate. So whenever that you see CA, that stands for certificate authority, it's just a role for a system to give out these files or these certificates that would represent what trust level the other system can have. It's just like how, you know, you have different set of friends. Some you trust more than the other. Maybe your best friend, you trust them with everything, all the information about your family, your life, or even if something happens to you, your bank account, right? And then other friends, you have little trust level. So with that, we can use the certificate to control how the system communicate through that trust model, right? Some have more trust, some have less trust, some have zero trust after they don't pay, right? So that's what CA is for. So if a system encryption key is compromised, what should happen next? You should revoke that certificate immediately because that certificate represents trust for that system. And once it's established trust, right, there are other things that would be implemented with access. This is a very important area because certificate plays into a lot of different things, but particularly encryption. It goes into communication, right? And then also synchronization for server systems and other areas. And even when you're working with vendors, like third-party vendors, partners, certificate is also used. As web users, you are issued certificate. When you install an app, like a game app or a banking app, it installs a certificate on there, right? With that, you are allow or disallowing certain things like your camera, you know, for credit card information, your microphone, you'll be able to speak into the app. So if the system encryption is compromised, right? We already talked about the revoke of the certificate for 24. What type of certificate is used to hold the private key? And we would use the P12 or the PFX. I think I put some information on there for you about what these are. So private key is used in PKI infrastructure. We generate two keys, public key and a private key. Remember what we said about storing or holding the private key or anytime you're doing key exchange, the process in that is very important. So there are certificate, its job is to hold or maintain the private key. And then for the last, for number 25 is, it's called Open PGP. PGP stands for pretty good privacy, right? So at one point, you're gonna become like me, second nature to all acronyms, and that's where you need to be, right? As professional, pretty good privacy. It is used for email. Now, non-open PGP proprietary product has been acquired by Symantec, which is owned by Norton. This is implemented with their security software, but the industry continued to support the technology that was originally open source. So you do have other products that are similar, you know, so if you want to do email encryption, this is the thing that you would want to look into. So we can click this link. And then it tells you that this is the RFC standard, right? This was originally created for pretty good privacy by Phil Zimmerman. And then under operating system, we can click learn more. But it listed Windows, Mac OS, Android, iOS, Linux, browser-based plugins, right? So if you're using Chrome, likely that you have Chromebook, I should say, likely that you need to use browser plugged in because Chromebook is not really designed for native application that you can install on that system. But if you're using all the other OSs, right, like iPhone or iPads, Android, so there are many different options. Okay, and then under each one, I just want you to identify a couple of the products that you can use. So going back to their website. So I have Android. So my option would be these. And they change from time to time, right? R2Mail2 been around for a little bit, but you can just select and you can click on them to find out more. Canary is common for Apple systems. Claws Mail for Linux. Cleopatra, I've seen this around for a long time for Kmail. Thunderbird, A lot of people use Linux-based system also use Thunderbird and it works well with Firefox plugin. And then there are other webmail provider plugins. So if you're using Yahoo, if you want to implement encryption with Yahoo or Gmail, you know. So when you install the plugins, it's going to ask you for authentication to those applications. And then you're going to have to accept the term of use and all the additional things, right? For the plugin or Outlook.com. Just keep in mind that when you encrypt email, it is going to be slower. You know, so it does slow down the process because it does have to validate things. You know, but if you send a lot of sensitive data, consider using encryption, you know, not for personal level as well, right? But at the company's level, we always implement options for people to use encryption with email. You should, especially when you deal with a lot of PII. Okay, so that was 25, just to go through and look at some options. And that would wrap up our assignment. We will need a drive to copy our Windows virtual machine.